Scotland clearly figures largely in wave and marine energy power, and the University of Edinburgh is not to be left out. Indeed, it's one of the centres of excellence. I'm joined now by Henry Jeffrey from the university. Welcome to the broadcast.
Thanks very much.
Why is Scotland so important in this dimension? At this meeting, so many of the people are from Scotland, and so many of the ideas are Scottish, and technologies are being tested in Scotland.
Yeah, I think it's fair to say that United Kingdom and Scotland has a long history in the development of marine energy, starting at the University of Edinburgh in the 70s with the Salter duck, invented by Stephen Salter back in the energy crisis that we had there.
What was the Salter duck?
The Salter duck.
Oh, Salter duck,
Yeah.
I beg your pardon.
And this was a string of duck-like shaped.
Yes,
that
I
would
remember,
rotate-
yes.
They would rotate in the sea and be strung together in order to have a very, very high capture efficiency. But going back to your original question as to why Scotland is so represented here and there's such an interest, I do a range of strategic road mapping roles within the university that we do for many countries. And when I speak to these countries, they're interested in three main things in particular with regard to the development of wave and tidal power. They're of course interested in the security of supply that they get from this new technology. They're very interested in the carbon savings that they get from having a clean renewable energy. But they're always very, very, very interested in the economic benefit and jobs that can come from this sector. And Scotland is no different. They're interested in the security of supply, they're interested in the carbon savings, but they're particularly interested in the development of the technology, the jobs and the economic benefit.
And you've got the
that can bring.
coastline. You've got the coastline with various conditions that are good for testing and ultimately would be good for power generation.
Absolutely, and that's the key to having the security of supply, that we have the raw resource, and we have one of the best resources in Europe, certainly for tidal power and for wave power. So we're blessed with the raw resource in Scotland, but we're also blessed with the political will that recognises the economic benefits and the other benefits that I mentioned. So we have the underpinning supply chain, the test centres, the political will, the academic and industrial research base in order to develop these technologies.
When you look at the commercial endeavours, and you see a lot of them, I'm sure,
Yeah.
from your position as a research fellow at the university, do you feel drawn personally to one over the other? Do you feel that some are more promising than others?
Well, I think that I wouldn't say at present that some are more promising than others. What I would say is that some are more mature than others. That there are certain technologies, many of them represented at this conference today, that are much more progressed than other technologies. I think that the key indicator isn't what Henry Jeffrey at the University of Edinburgh says with regard to the promising technologies. I think the market is starting to speak for itself, and we see that the large original equipment manufacturers such as Rolls-Royce, Voith Siemens, and a number of others, Alstom Power for instance, they're all taking stakes or buying out these companies, and I think that's the indicator that they're recognising mature technologies that show promise.
Do a lot of the companies sort of act as farm clubs in the hope they'll be bought out along the way when their technology is mature? Or is generally the feeling in these companies that they can go it alone? Or do they hope to be bought out by the large engineering companies?
Well, I think I think that game is played, but I think that game is played more in the investment community. I think I entered the sector 14 years ago and worked for one of the commercial technology developers, and at that point in time, venture capitalist money was predominantly the money that was available for this sector, and it would bring you perhaps an unrealistic timescale, no technical input from your investor, and they would certainly have an exit strategy. They would want to sell you or float you at some point in the future. I think that situation has changed now that we're seeing these large companies, the Alstom Powers, the Rolls-Royces, as I mentioned earlier, that they're bringing not just investment, they're bringing a huge amount of technical expertise and they're bringing a very realistic timescale with regard to the development of energy technologies. So I think that it's not so much the company's desire to be bought, I think it's the recognition of the investment sector that moving to larger companies is one of the routes forward for the development of this technology.
Henry, do you see any generic problems, across the board problems, say corrosion, say securing the devices to the seabed? Is there one common problem that all developers with all technologies face?
I think there are a number of common problems. I think that and there are a number of very, very important ones, and I would be reluctant to have to bring it down to one. But if I did have to bring it down to one, I'd probably bring it down to survivability. But survivability has a number of things associated with it, with such regard to the manufacturability, the reliability, the operability, and of course the affordability comes in as a main factor that allows you to make those things work.
So that you don't want to see the machines either fail, that's what you mean by survivability, or wash out to sea, or in some way go offline, maybe forever. Materials is a lot being, every time we do something new in engineering and science, we tend to learn a lot about materials when we thought we already knew a lot about materials. I remember in the early days of solar power, I went to see an engineer I knew quite well at the Sandia National Laboratory here in America, the great weapons laboratory. And I said, "What have you learned?" His name was Scott. I said, "Scotty, what have you learned?" He said, "I've learned a lot about bonding steel to glass." Well, I thought we knew all about bonding steel and glass, but he said, "Oh, no, not for this application." So do you see a lot of spin-offs, a lot of things that are going to be useful elsewhere in the world of engineering and applied science?
What I see is that at this point in time, the spin-offs, I think, are happening in the opposite direction. Wave and Tidal, at this point in time, is quite a small sector, and it has the opportunity to partner with organisations such as the Sandia National Lab that's done a huge amount in both materials and coatings for military and for on and offshore wind. And there's the opportunity that things like materials, those problems or those challenges aren't particular to the wave energy sector. There are other sectors such as the Navy or the wind, as I mentioned, that you can transfer those applications into this sector. So there's a huge amount of technology transfer opportunity to other sectors, but I'm sure, as you said, once this sector grows and emerges, that transfer will happen out of this sector as well. I think it's an inward route at present. As we mature, learn our lessons, that will transfer elsewhere as well.
Does the environmental impact come into your portfolio? Do you look at the environmental impact of each installation or potential installation, both on marine life and on the environment in the larger sense?
Within the UK's underpinning research for the sector, we have an organisation called the Supergen Marine Consortium, which is led by the University of Edinburgh, and I manage the academic, industrial and research networks within there. And we have groupings, because we don't just do all the work at Edinburgh, we partner with a number of other universities and research institutes across the UK, and we have the environmental impact as one of those topics that we look at. I think it's particularly interesting, environmental impact, with regard to wave and tidal, because it's an industry that doesn't have a binary approach. It's not as if you have one device today and 1,000 devices tomorrow. You have a very iterative approach of having a single demonstrator, then maybe a small array of 3 or 4 devices, then maybe 10, 30, 50. So the regulator can take a lot of comfort that it has a great opportunity for adaptive management. It doesn't need to take a precautionary process because we need to find out everything now, because once we say yes, there's thousands tomorrow, it's not that you're going to have this power station coming on board just like that. So I think that the environmental impact is a great opportunity for adaptive management here.
It has tended to be the case with alternative energy that people who support it, lay people, tend to think that it's been benign, that there is no environmental impact, that if there's no combustion, there's no environmental impact. In fact, nothing is benign, is it? Everything affects something in some way. Not so?
Well, of course, there will be effects from wave and tidal power. Some of those effects will be positive, some of those effects will be negative. There's no getting away from the fact that if you are to install a tidal turbine by a piling method and you have to drill into the seabed, of course that's going to have an environmental effect at that installation phase, but the overall effects is over the lifetime of the device is what you need to take into account. So of course there will be impacts, but that needs to be put in context of the overall impact.
There's a great excitement, if I might be so crass as to say there's an electricity at this conference about these technologies, that they're now coming along, they're being tested, they're ahead of it, they're off the drawing board. Do you feel that this is in fact a very special time in the development of these technologies?
I think it is a very special time. I've worked in this sector for just over 14 years now, and I think that if I was giving this interview with you only 3 or 4 years ago, I wouldn't have been able to give those examples of Rolls-Royce, of Alstom Power, of Voith Hydro entering the sector. So I think it's really on the cusp of moving from demonstration and deployment of single devices to moving into a real commercial sector. So I think this is probably the most exciting time. It's been an exciting sector the whole time, but I think this is the point where it becomes very, very exciting.
Henry, why do you believe it has taken so long? We started looking at alternative energy in the 1970s, 74, basically, after the Arab oil embargo shook up the whole world. Why has it taken so long? There was work on ocean thermal gradients and a few other things, but the big drive in wave and tidal power that was anticipated didn't happen. Why do you think there was that lag?
Yeah, well, it was clear that in the 1970s, certainly in the United Kingdom, we had the oil crisis that was a big drive. That oil crisis went away, as did the political will at that time for the production of renewables. And so the production of renewables, especially wave and tidal, has suffered from a stop-start approach with regard to political will. It's only recently, in the past decade, that political will, perhaps driven somewhat by climate change, has given a continuous political will, not just in the UK, not just in Europe, but globally there's this interest. And so this has given the continuity of funding of the innovation supply chain that has allowed us to make great steps in the past decade that perhaps we had the opportunity to make several decades ago.
Fascinating. Thank you very much, Henry.
My pleasure.
Lovely to have you on the broadcast.
Thanks very much.